Okay, hello and welcome. So in this session, I'm going to cover regression and correlation. So the best way to actually cover this topic is to do it by an example. So I'm going to share my whiteboard with you. Just going to make sure this session is being recorded. Yes, it is. Okay. All right. And I'm going to go to the whiteboard. There we go. All right. So regression. What is regression about, and what is its use in the real world? So regression has a lot of value in that it basically allows you to make predictions. The predictions, um, they won't necessarily be spot on. Sometimes it is, but it isn't far off the mark if we assume that past data or past experiences is a reflection of future outcomes. Okay, and it's a fair assumption in most businesses. We have nothing better to work with other than past data to make estimates on future outcomes. All right, so let's look at this example here. Okay, so what we're trying to do is we're looking at these individuals, Jill, Sarah, Emily, all the way to Ethan. So this is our sample, and what we're measuring here is we're looking at their experience in the industry in months and against their annual salary. Now, often in this section, you will be asked to determine what is the independent variable and what is the dependent variable. Now, what they mean by that is, for the independent variable, it's the variable that isn't affected by any other variables. Okay, now what do I mean by that? Okay, so let's just look at Jill, right, for example. If Jill goes for an interview with a recruiter, uh, and what happens is they question Jill and they ask about her experience, which is a common question when you go for a job interview. Now, based on their experience, they will kind of have an idea of what salary bracket you should be in. So it isn't the other way around. They don't ask you for your salary and then try to determine your month's experience. So you can see that your experience affects your salary, not the other way around. So because experience affects your salary, then it's your month's experience that is actually your independent variable, which is why we have it here on the x-axis. So this is your independent variable, which is why it's on the x-axis. And if that is your independent variable, then the other variable, salary, has to be your dependent variable. Okay, so that's your y. And often, if you were asked to draw a scatter plot, you would have your dependent variable, in other words, the variable that's represented by y, on the vertical axis, and your independent variable on the horizontal axis. And what these blue dots are is it's basically just plotting the points that you have for this table. It's these first two columns here that you have. Right? It's your month's experience, this x column. So let's put an x here, and it's your y column. So for Jill, her experience is 52 months. So 52 months is somewhere around here, and the corresponding annual salary for Jill is about 381. So it's here. You're mapping that blue dot to represent Jill. And each blue dot represents each row in this table. All right. And that is basically your scatter plot. All right. So now that you kind of understand what the data is, you understand what your independent variable is and what your dependent variable is. It's very important that you identify that so you know which column represents your x and which column represents your y. All right. Because you're going to be using these equations on the right, but don't get too stressed about it. I'll explain them in a second, and you don't have to memorize them because they're given to you in your formula sheet. All right, so what regression does is, and they often ask you to determine the line of best fit. Now, what do they mean by the line of best fit? Okay, so let's look at this data that we have here, or any data, so to speak. Draw This is your x-axis. So this is your x, that's your y. Now say we had this data, I'm gonna maybe put it in a different color because I like my colors. There's your dots here, data points. This is some make-believe data. I think that's about, let's make it one more there. All right. The line of best fit is basically which line can best represent this data. So what happens is I could come along and I can just draw a line here in red. My line will be represented by this line. And then you could come along and say, okay, hold on, I can do a better line. And you come, oops, right? Then you come along with a red line, right? And so on and so on. Okay, so we can go on like this with a lot of lines that we claim to best represent this data. But that becomes very subjective. So in this course, we actually determine the line of best fit in an objective manner, and that means it cannot be disputed by anyone else. And how you find that line is by using these two equations. Now, what makes that line specifically the best equation, the best line? So let's delete this line, right? Let me delete this line. Let's say this black line is the best line. Okay. Now, what makes it the best line is that what we have is, we call it the sum of squares. Now, what do we mean by that? Okay, each point has a vertical distance to that line. Okay, so from here to the line, there's a vertical distance. This point has a vertical distance. This point, it's very close. You can barely see the line. The next point has that distance, which you can see, and so on. Okay, each point has a distance to the line. Now, what you do is, if you measure the distance for all of these points on the line, so call this point 1, the distance, that vertical line is 1, this line is 2, 3, etc., all the way to all of them. If we had to add them up, we add those distances up, 1 plus 2 plus, and you can see the 1, 2, 3, 4, about 7 points, all right? So we add up those distances, and each one of them we square them. And why we square them is because the thing is, we don't care whether one point is below or above it. Okay, we are only interested in the length. So when we square it, we're making sure everything is on the same side. So we square them up and we add them up. Right, so we square them and we add them up. What we want, now think about it, right? If a line fits data very well, so say we have this line, it fits data very well, we want every single point to be on that line. If every point is on that line, then the distance from each point to that line, that vertical distance that I'm drawing here, this vertical distance, is like 0 because it's on the line. So that means if I'm adding up these distances, it's basically 0 squared plus 0 squared plus all the way to 0, which gives me 0. So a line that fits data very well has a distance or a sum of squares close to 0. All right, that will be the best line. So in general, any line that gives us the lowest value for this is the best line, right? And how you find that line that gives you this lowest or minimum sum of squares is by using these two equations. You don't need to understand how these equations are derived, okay? It's beyond the scope of this course. All you need to know is that you need to trust that these two equations give you the best slope and intercept for the line that will represent the data. All right, so that's why we use those equations. It's basically to find that line. All right, so let's use those equations to find the line. Find the line. And remember, for some of you did maths in school, or maybe as a recap, I believe it's probably grade 9 maths, but I'll explain it now. What kind of differentiates a line or makes a line unique, right, is its slope and its intercept. So the equation of a line is y equals mx plus c. All right. This is your slope, or in other words, your gradient, and this is your intercept. And these are the values you need to find. All right. So these equations tell you what the slope and intercept is. So this b, this is your slope, right? And this is your intercept. This is your c. In this section, we represent it by a and b, but you can see your formula sheet. Your formula sheet might have b1 instead here. It might have b1, and it might have b naught here. But just know it's the same thing. It's just different notation. All right. Okay, so we are gonna find the slope and the intercept, and then we're gonna write out this equation. All right. So let's erase this. All right. Now, if you look at the equation, the first of the variables that you want to solve is the slope. Because if you look at the slope, this equation for b or b1, right, it doesn't depend on a, right? It doesn't depend on a. It only depends on n, sum xy, etc. But if you look at the equation for a, for the intercept, you can see that it does depend on b here. All right. So that means you have to work out b first. You have to work out the slope first. And that just means finding all the values that you need to plug into this equation. Now remember what I told you at the beginning, it's very important to identify which column is your x and which column is your y. Because to find the values that go into this equation, it depends on that, right? So the first thing that you can see that this equation is looking for is sum xy. Now what that means is you need to multiply all the x's with the y's first. You multiply all the x's with the y's, and then once you've done that, then you sum it all up. That's what this symbol means, which is what we're doing in this column here, right? We're multiplying the x, which is 52, times 381, and we get 19,812. We do the same thing all the way to the last row. It's 77 times 610, which gives you 46,970. And then right at the bottom, the last row, we add them all up. So basically, we're going to add up this entire column, all the values of the rows. We add up all these values, and we get a total of 243,305. So that's what this value is, this term. It's 243,305. All right. Then the next thing in the equation that we want to find is sum x. We want to find sum x, and that just basically means summing up the x column. And we've done that here, and we've got 472. 472. Then you can see the next item in this equation is your sum y here. So sum y, and that is adding up the y column, which is 3,550, 3,550. And then you can see in the denominator you got something that's a bit different than just sum x. What it's saying is, okay, you got this notation here. Okay, what that means is you must square each x and then add it up. So in other words, if I say, say x only had two values, hypothetically, right? Say x takes on the values, you can take on the values 1, you can take on the value 3, and one more value. Let's say it takes on the value 4, right? If I want to find sum x squared, that means I must take each x value, so it'll be 1, I square it, then I add it up to the next value, which is 3, I square it, and then I add it up to the last value, which is 4 squared. Right, so you square each value and then you add it up, and that's how you get it. So that's exactly what you're going to do here in your table, is that you need to find your x squared values first. You need to square each value. So this is your x squared column. What that means is you take the first x value, which is 52, you square it. You raise it to the power 2, and you get this value here, which is 2,704. and you do that going through all the rows until Ethan, the last row, which is 77. So 77 raised to the power 2 gives you 59,000. Sorry, not 59, 5,929. All right, and that's how you get this column. And then we sum it all up. We find the total here, and that is your sum x squared. Okay, so that's this value here, 32,252. All right, this last value here, you actually don't need to find it, because what it's saying is you need to take this value, the sum x, and you raise it to the power 2. So that, in other words, you take the 472 and you raise it to the power 2. That's what that last term actually means. That's the difference between these two. Okay, make sure you understand that. So what we're going to do is we're going to plug all these values, right, all of them, into this equation and get the value for b or b1. And if we do that, right, I'll call it b1. Right, we do that. I'll do that now in a second. Oh, you also want to, sorry, you can see the equation also asks you for n, right? N is not actually something you need to calculate. It's just basically how many rows of data do you have. Okay, it's how many rows of data do you have. And if you count them all the way from Jill all the way to Ethan, it's 1, 2, 3, 4, 5, 6, 7. There's 7. So your n is 7. It's how many data points you have. Okay, and you can plug all those values into your equation. And give me a second, I'll do that. All right, so it's 7 times your sum xy, which is this value here. As you plug all that in, so you get, it might be a bit too big to write this, so I'm just going to give you the final answer. 243,305 plus, sorry, minus, okay, I'm onto this part here. Now it's a sum x. It's your sum x, which is 472, times your sum y, which is 3550, right, divided by n, which is 7, sum x squared, which is this part here, is 32252 minus 472 all squared, the last part here. All right, so it's 472 all squared, and that will give you a value of 9.2. We'll round it to 2 decimal places, make it a habit, okay, at least 2 decimal places. So I get a value of 9.2399. All right, so if I had to round to 2 decimal places, it will actually be 9.24, right? So that should be good enough. Okay, so that is our slope. And then the next thing we need to find is the intercept, your a, or in other words, your b naught. All right, same thing. So we're going to plug in our values here into this equation, your sum y, your b, sum x, and n. But if you do that, you'll get a value of give me a second. Okay, you get a value of minus 1. What is this? Yeah, minus 115. 115.89. Round to just 2 decimal places, it becomes 9. Because you have 8, 9, the decimals are 8, 9, 7. So when you round the 9 up, it becomes the 9. Right? And then you can finally write out the equation. Okay, so I'm going to write that out somewhere around here. what you want to do is you want to write the equation out. So you would say y equals your gradient, which is 9.24, x plus your intercept, which is minus 115.9. All right. And then what you want to say, leave a statement at the end of this is, remember, for all regression equations, right, for the line of best fit, it's only defined within a certain domain. And what do I mean by certain domain? That means a certain interval of x. Now, if you look at your x values, your x values start from 52, and the highest x value you get is 77, right, which is Ethan's month experience. So it goes from 52 months, so it goes from 52 months all the way to 77. All right, and then what you would say is for, I'll write this in text so it looks a bit better. All right, after you write the equation, you want to, oops, what is it? One second. Let's say for I'm going to actually just erase this and write with my pen. My stylus is giving me issues. Okay, so the statement you want to write here is for how you write between mathematically is you can write it like this: the lowest value first for 52 less than equal to x, and the highest value on the right less than equal to 77. But if you're not comfortable writing the math notation, you can just say for x between 52 and 77 in words. That's still fine. Okay, but I just wrote it here in a mathematical term. It's up to you, but it means the same thing. All right, so it's very important that you leave the statement here. Now, why is it so important? Okay, the reason being is that what happens is, remember, you have your line. Okay, you have your data. Your line is fitted to data, say within this specific range. Okay, so you fitted your line to this data here. But what happens is, past this domain, so further more on the right, you don't know how this data could actually behave. This data could actually change direction. And so what happens is you fitted this line going straight up, but in actual fact, the data starts turning or changing direction. It could change direction even in a sharper way going up like this. So we don't know, okay? We can only fit this line for the information that we have and for the domain that we have, or in other words, the limits of x that we have in our data set. All right, I hope that makes sense, which is why you need to put that statement after you've stated your line. So very important in your exam, your assignment, you must okay, show how you got these totals, right? You can even pull them out in your calculator, it's still fine, right? And then you want to plug these values into your equation, right, to get your slope, get your intercept, and then you want to leave the statement here. You must show your equation and you must show your limits of x. Just a hint, say you were working out b, right, or in other words b1. If you were working it out, show the examiner that you plugged in the values in the equation. In other words, your b1 is, if you're following this equation here, you would show your n value is 7, which goes into your sum xy, which is this one here, which is here 243, right, 305, minus your sum x, which is 472, times sum y, which is 3550, right, divided by n, which is 7, into sum x squared, which is this here, 322 4.52 minus 472 all squared. So you need to show that you've plugged in the values into the equation. You will get marked for this, so make sure you show this, okay, please. You showed the working, and then in the end, you need to get the value of 9.24. And you do the same thing for your intercept. All right, so that's how you find the line of best fit. Now you can get asked, okay, you've got the line of best fit, okay, use it to make a prediction. And that was the, the essence of this section, in that you can make predictions, right? So if someone with a certain amount of experience comes along, so let's say someone with an experience of, let's say 57, so somewhere here, right? Someone comes in 57, but we want to know what annual salary does that person likely make. We need to make a guess, right? And how we do that is we plug 57 into our equation here, and we'll get the y value. In other words, we'll get the annual salary. So the predicted y, right? We generally write a predicted y with a copy on the top, right? That's this notation. What is important is that you just know where to plug in the value into the equation. So remember, we're trying to guess, make a prediction of someone who comes in with 57 months of experience. So we're going to plug that into our equation, 9.24, right? 57 instead of the x, minus 115.9. And if we do that, we'll get a value of, I think around 9.24, sorry, times 57, 410. All right, so that person will make about 410. Just keep in mind, the salary is actually in thousands, right? So this is your annual salary. Your salary is in thousands. So this person makes about 410,000 per annum. Okay, if this person has about 57 months of experience. All right, that's how you use the equation to make predictions. So you can leave a statement and say the person is estimated to have an annual salary of 410,000 per annum. All right, and that's how we use the equation. Okay, then the next part is basically so you've got your line of best fit. Okay, the next part you can get asked to work out is your correlation coefficient. All right, now when you erase this, so I'm going to keep that. Squared. Okay, your correlation coefficient is represented with the letter R. Okay, and it has its own equation. It has a very long equation, so I will get that for you. I'll show it to you, but it's in your formula sheet. Second. Oops, here it is. Okay. I'm going to paste it here. There we go. It's a nasty looking formula, I know, which is why you'd have to determine all the values that actually go into this equation. All right, and you can see in this table that I've done on the top here, you basically have all the values you need to plug into the equation. Okay, here. All right, so you're going to plug all these totals in. So basically, if you look at this equation, it's asking you, so let's start on the top. Excuse me. If you look at the numerator, it's asking for your n, which is 7. Right, then it's just sum xy, which is 243, 305. Right, minus sum x, which is 472, times sum y, which is 3550. And I'll explain what this r actually means after you work it out. Okay, it's better to explain once you got the value. And that's divided by the square root. Okay, right. Then the first part, it's your 7, it's your n, times sum x squared, which is 32252. All right, minus sum x squared, which is 472 all squared. Right, times the next value, which is 7, which is your n here now at this point, times sum y squared, which is this column here. There's your y squared column. Just like how we did the x squared column, we do the same thing for the y squared column. And the total there is 1.8 mole. Right, so it's quite a big number. So I'm going to go into the next line for this one here. Right, it's continued. So it's 184 658, right, minus some y all squared, which is this 355 all squared, close bracket. And everything that you see here, and I'll put in a different color bracket, everything you see in this denominator starting from here to here is under the square root sign. Right? Everything's under the square root sign. Now you need to show the examiner. Now my advice to you is show this working. You do have to show this working here. You have to show the examiner that you've plugged in the values into the equation. It's very important that you do that. But when you're actually getting the value for r, I wouldn't recommend trying to put all of this into the equation in the calculator and pressing equals to. My advice to you is enter all these values in the regression function in your calculator. I'll explain how to do that now for your Casio calculator. All right. Your calculator can do all the hard work for you, right? And it'll make your life a lot easier and also decrease your chances of making an error. All right, so what we're going to do is, with your calculator, all you need to do is you need to specify the regression function. So how you do that is, give me a second. Sure. With your Casio calculator, all right, what you're going to do is you're going to press mode and you're going to choose the stat option. In my calculator, it's option 2, so you choose stat, and then you'll see 2 options. Okay, one of those options that I want you to focus on is it's an option that has a plus bx, and you can see this looks very familiar to that equation that we worked on in the beginning. All right, there's your intercept, there's your slope. All right, so this is the option you're going to choose. In my calculator, it's option 2. So you're going to choose that option, and then you'll see on your display in your calculator, you'll have an X and a Y column, right? And what you're going to do there is you're going to capture all your X values, in other words, your months of experience, and you're going to capture all your Y values here, which is your annual salary, right? Your annual salary. All right, so I'll do that now. I'm just checking, is anyone in this session? No. Okay, so I'm just going to do it. I was hoping students would be here so they could also do it along with me. So we're going to capture the X values, 52, 63, 67, 66, 73, 74. Okay, that's about 7 values. Now we're going to capture the Y value. We're starting with 381, 442, 472, 518, 533, 594, and 610. Right, so we've got all the x and y values. Right. Now, if you wanted to get the r, right, if you want to pull out what the correlation coefficient is, right, all you need to do is you're going to press shift in your calculator. So you press shift, and then you're going to press the button 1, which has stat above it, and then you'll see an option that says var. Okay, variables. That's what the var stands, variables. So you can choose that option, and then you should see. Oh, sorry, my bad. Figured I said that. Sorry. Let me go back. You're going to choose the option reg. All right, so you're going to choose. You're going to press stat. Sorry, my bad. You're going to press shift. Okay, so you'll press. Let me write this down. You're going to press shift. Right. Then you're going to press the button 1, which has stat above it, and you're going to see the option that says regression, REG. All right. And that is option 5, my calculator, and then you'll see R. You'll see it on your calculator. And all you need to do is press equals to, oh, sorry, and you get 0.949. You get 0.94. Let's round it to 4. In my case, 949.7. That's good enough. That's as accurate as you can get. So that's your correlation coefficient. Now, what your correlation coefficient tells you, now this value can be a negative or it can be a positive. Now, what does it mean when it's positive? It basically means that your data is positively correlated. Well, what does positively correlated means? Well, if you look at if you look at this data that we have, just by looking at that plot on the top right, the scatter plot, what that's telling you is it shows you that as your x increases, okay, so as the number of months increases of experience, so does your salary. So they move in the same direction. When one increases, the other increases, and that's what you would expect for your months, for your years of experience on the job versus your salary. As your experience increases, your salary increases in most cases, right? But there are some cases where your x can increase, but your y will decrease. Okay, there are cases where that happens, and I'm sure you can think of scenarios in that sense. So think about it. Inflation, if as inflation increases, right, then your earning power starts to decrease. Okay, so they don't necessarily move in the same direction. There's a lot of other things you can think of that has a negative relationship. But in our case, for this data, you can see why it's positive, because as your experience increases, so does your salary. Now, as a guideline, when your R is greater than 0.9, then it's a very strong relationship. When it's greater than 0.8, then it's considered strong. All right. In our case, it's greater than 0.9, so we would say it is a very strong positive relationship. Okay, very strong positive excuse me, relationship. All right. That's how you interpret this R value that we got. We got an R value of this, so we would finish off with a statement by saying very strong positive relationship. All right. Okay. The last thing I want to finish off with is called your coefficient of determination. Right? It's quite a mouthful, but I'll show you basically what it means and how you calculate it. So all the hard work is done working out R. So when you are asked for your coefficient of determination, so I'll write it here as coefficient of determination. All right, that is basically your R squared. What it means is you just take whatever you found for R and you raise it to the power 2. So in other words, it's our 0.949. 0.997, and if we raise that to the power 2, we get a value of 0.9, so it's about 90. I'm going to write it as a percent, okay, because your coefficient of determination you express as a percent. So it's 90 point, let's leave it at 90.19, rounded to 2 decimal places, percent. All right, now how you explain this, or how you interpret this, is you would say, and I'm not going to write this out, so I want you to give it a try, but I'm going to say it so that you understand it. It means that about 90, or we can be more exact, let's say 90.19% of the variation of our annual salary, or in other words, the y variable. But when you interpret it, you don't say y, you mention what the y variable is, right? In general, your r squared explains the percent of the variation of y that can be explained by your x variable in general. But when you're answering it, you answer it in terms of the problem that you're working with. So you won't say x, you will say month's experience. For salary, you would say, so instead for y, you would say salary instead. So how you interpret this is you would say 90.19% of the variation of the annual salary can be explained by month's experience. I'll say that one more time. How you interpret the coefficient of determination, in this case, you would say 90.19% the variation of annual salary can be explained by month's experience. All right. Okay, and that's what I wanted to cover today for regression. So those that are going to watch it, I hope you enjoy it, and I hope this helps you understand this section. All right, that's it from my side.